This is going to be our third example of the exact same thing. So I highly recommend you to pause the video and see how far you can get on your own on example 4. Okay, I hope you've had a chance to pause the video and see how far you can get on your own. I've kind of set this up for us to start. First thing we need to do is set up our table. Since I have 2 equations, we're setting up two tables. So the first one is when y equals negative 3x, and my second one is when y equals positive 3x. So what number needs to go in both of these tables here? Well, where is this graph breaking? This is breaking at 0. So right here in the middle. Okay, so we're going to have something over here to the left and something over here to the right, but we need to know what's happening where this graph is changing. So zeros right here for both of them. So which one gets a closed circle? Okay, the second graph here, because the second one is when x is less than or equal to 0. So nice, bold, closed circle. And this one is just when x is greater than 0, so open circle. So let's put some other points in here. We have 0. And I'm wanting things that are greater than 0. You can also use that as an arrow. So what is greater than or to the right of 0? We've got 1. And that's really all you need, but I like a couple more. So we're going to go 2 and 3. Okay, so let's find these values and then we'll graph this side. So when I substitute in a 0 into this equation, we're going to get 0. Negative 3 times 1 is negative 3. Negative 3 times 2 is negative 6. And negative 3 times 3 is negative 9. Now, I can't fit that last point on. I'm going to kind of fit that third point in there. So my first one is an open circle. It's kind of sloppy. But that's an open circle right here at 0. And then we have 1, negative 3. This is not an open circle. It's just a regular old point. And then 2, negative 6 is slightly off my graph right here. So here is the right side of my graph. So now let's fill this out and get my left side. This one is when x is less than or equal to 0. So what numbers are less than 0, or use that as an arrow, what numbers are to the left? So we've got negative 1, negative 2, and negative 3 right here. So plug in your values. 3 times 3, or well, we'll go down there, but 3 times 0 is 0. 3 times negative 1 is negative 3. 3 times negative 2 is negative 6. And 3 times a negative 3 is negative 9. So plot this as 0, 0. I'm going to put a closed circle. I already have an open circle here. So now we're just going to shade that in. Now we have negative 1, 3. And negative 2, 6. And I can't really fit that last point on there. So we'll go from this point through the rest of them. This right here is not a question you're going to be asked, but I'm still going to put this, and you can choose to include it or not include it on your notes. But this right here is considered a continuous function because these two sides right here connect. On this other one, this is not considered continuous because you cannot draw this graph without having to pick up your pencil. This one here, you could draw with one pencil stroke, and so this one would be considered continuous. This is also the bit that's a stretch. This is a graph of what your absolute value functions look like. Absolute value functions make this V. So we have graphed technically the absolute value of 3x. So continuing on here, part B wants us to find f of 1 and f of -2. Pause the video, see if you can find those two values. Okay, I hope you had time to pause the video. F of 1 is right here. When x equals 1, my y equals -3. And my f of -2 is over here. When my x is -2, my y is -6. And then lastly, my domain. You can use the graph or your piecewise defined function. If we use a graph, as I go from left to right, we start with an arrow, so -infinity, and then it's going to keep going. We have no break even on our breaking line right here. No break, and then it's going to keep going to infinity. So our domain is all real numbers, which is what's told to us in our piecewise defined function. It says every number greater than 0 and every number less than or equal to 0. That's every number possible.